Good morning, all. I am Kaushik here. Today we will talk about linear regression. First of all, linear regression is one type of supervised machine learning. So there are some of the key points I mentioned here. Uh, so linear regression is one type of supervised model, and it's predict the task in a real value numbers. So what does it mean? Suppose if we have data like this, and this data I took it from the Kaggle, and it is like a house pricing information, like based on the number of bedrooms, bathrooms, square foot living, square foot lot, we have the house price information here. So how the model actually work? It take those features and the target. So for example, in this case, the target is the price and features are the remaining things are features. And all these things we are incorporating into the model, and then model is doing the final prediction on the unseen data or unseen values. And at the time of this, model is creating the parameters. For linear regression, there is no hyperparameter, but our task is to basically using the optimization and make these parameters the best so that we can create a best fit line. So if we have a linear relationships, for example, let's consider this kind of example where we have a house price, as a target variable, and probably square foot of the house is our feature. So if we plot in a graph, probably it will come something like this. As the square foots are increasing, house price will also increase. So it will create a best fit line. So this is we called best fit line. Okay, so that's the main objective of the linear regression, that create the best fit line or create the best function, and at the time of identify those parameters. For the simplicity's sake, we will first discuss about the univariant linear regression. So let's consider univariant or you can say simple linear regression. So what does it mean? Univariant mean you have only one variable. So how the function look like? It will look like something like this: beta 1 x plus epsilon. Now in this case, this beta 0 is my coefficient, or you can say intercept also. Intercept, and beta 1, this is basically the slope for this particular features, and this residuals is my errors, because whatever you do there will be always some error, so we have to calculate that for the final value. So this is the function for the univariant linear regression, and this model is basically trying to get the correct value for these parameters. The more accurate these values, we will create these functions properly. So now obviously our next question is, how do you determine this coefficient? So what we will answer in now next, how do we determine the coefficients? So basically how we will calculate this beta 0, beta 1. In this case we are talking about univariant, but when we'll talk about multivariant there will be more coefficients one coefficients for each features. Okay, so now in continuation of that, so you are familiar with this formula. Okay, so this part is nothing but my prediction, right? So if I put this into a xy plane, what is my residual actually? Let's first check that. So let's consider my price is probably in to the power 6, and my square foot areas are probably 1000, 2000, something like this. But what intention is basically, let's consider that we have a best fit line like this. So some of the points, let me put in a different color. Probably some of the points are actually on this line, which is very good, but there are other points also which is not on this line. So that's mean whatever be the distance from the original point to this line, this is my residuals, this is my error actually. So that's the part we have to minimize. So our target is basically minimize this error. As much as we can minimize, the model will be the best fit actually. Okay, so one thing is, when we are considering this thing, so that's mean what we are talking here. And okay, I denotes basically number of samples. So if I have n number of samples, that's mean I value will be from 1 to n. Now let's consider few error matrix which are very much used, because we have to first understand what is the error matrix, how we'll calculate these residuals, right? These are called residuals. Okay, so first thing is mean absolute error. So this is something again, mean absolute mean, we'll consider the absolute value. So this is my original value and this is my y hat value, that's mean my predicted value, and divided by 1 by n is my mean absolute value. Now most popularly used is mean square error. This is very much popular, and the formula is again very simple. I forgot to add one thing here, I equal to 1 to n. Remember this, okay? So this is mean absolute error, and mean square error is basically again I1 to in, and then y original by y predicted, and then we are doing whole square. Now some of the people will ask this question, like why this is so important. This is, I will explain in later, but just for high level purpose, what exactly the benefit of doing the square is, first of all, like it will consider both your negative error and the positive error. It will not, when you will do the sum, it will not discard any of the error when you are squaring, because some cases you have positive error and some cases you probably have negative error. But when you will do the square, it will remove that negative sign and it will add that. And another thing also is very important, that is when your error, suppose you have 5 samples and out of 5 samples probably only one sample has a big error, you have to consider that. So that is another reason to basically using this square value. And another thing, y square, because it is helpful for the derivative purpose. Okay, so up to this I think it's clear. Now what is the technique to minimize this error? That is called, and very popular actually, least square method. This is called least square method, which we will use to minimize this error, actually optimize actually. Okay, clear. So roughly, like suppose if I try to draw a picture like error surface using MSE. Let me write it down probably here. Okay, so error surface for MSE, if I draw it in a three-dimensional plane, again it's little difficult because we cannot so let's consider this is my A coefficient, this is my coefficient B. So it will look like something like this. And what is our main goal? Our main goal is to find out this global minima. So this is called global minimum. Okay, so this is our main goal. So what we will do basically, if we take the derivative of the MSE, then we will find out this thing. So if we do the derivative of MSE of with respect to A, and we want to be 0, and if we solve this two equation, MSE derivative of B, and if we solve these two equation, we will get the value of beta 1 and beta 0. Okay, in my class I will not show the, at least in this session I will not show the actual algebra or derivative. Later I will show this thing, but I will share like what is the value of b0 and b1 finally is coming after doing this mathematical intuition part actually. So what we observed, like after MSc, like we found, like after derivative we found, we'll find basically the values for b1, and b1 value will be the covariance of x and y, and the variance of x, and b0 which will be mean of y minus covariance of x comma y and variance x and mean of x. So very much this will be our beta 1 and beta 0 after doing all the calculation by the least square method. We'll find these things. Okay, so this is the way we'll find the beta 0 and beta 1. One more thing I want to mention, like when it will come to the multivariant cases, because as of now we are talking about the univariant cases, but now let's focus on the multivariant cases. So multivariant cases will be something like that, because in that case it will be in the matrix format everything. So it will be y1 y2, and suppose we have n values, and we will have this, so 1, and then we will have x1 1 to x1 p, suppose we have p number of features. So x n1 to x np is the number of features, and then beta will be also beta 0 to beta p, because we will have this many coefficients. Okay, now when we'll do the derivative of MSE with respect to beta, what it will do, it will create x transpose x beta minus 2xt y plus 0. Remember, all these are capital X, don't get confused with the small x, equal to 0. That will give me the global minimum. So the beta value will come basically x transpose t to x minus 1 x t and then y. Okay, now this is the way we'll get the beta value for multivariate. But here one important thing is to remember that if there is a collinearity is coming into picture, collinearity is coming into picture, in that case we will not have proper value. So if you have a collinear features which are directly collinear, for example, suppose we have 2 4 6 and we have probably 4 6 8, this kind of features, then this will not produce the right solution. So we have to be careful on that. But almost all the Python packages are ability to handle this now. So but we will share some process like how to actually do the forward selection or backward selection kind of way, so that we can avoid the collinearity if there are multiple features with the collinear aspects. Okay, I think that's all for linear regression point of view. Next we will do some hands-on on the linear regression. Okay, so as of now, whatever we discussed, we basically discussed that okay, how we can determine these parameters and what is the best fit line, least square error. So basically all the discussion point was how to determine these coefficients, and we kind of high level understand that what we are doing, we have MSE, which is an error matrix, and then we are doing the derivative of this and we are finding out the final solution. Now the question is, okay, we found the solution, we found the beta 0, beta 1, but how well does the model fit? How well does the model fit? So this is my next question. And for that we again need some kind of parameter. And I'll show in OLS package, like we have a parameter called R square. This is the important parameter by which we understand whether what is the quality of the model fit. Okay, so first thing is, again I'm going back to my old picture. So same thing, this is my y, this is my x, and probably I will have some values on the line, others are outside the line. So these are my residuals actually, so these are my error. So when we are calculating this, so basically first thing is RSS. What is RSS? RSS is nothing but residual sum of square. So it's basically residual sum of squares. Okay, and how it is getting calculated, it's nothing but I equal to 1 to n y original value minus y hat. This is the RSS value. Now by this we can calculate the sum of the residuals, but the problem here is this can be a very big number, because if this y value is in millions, so this will be a very big number. So that's why what we are doing, that okay, let's consider another parameter, which is something like this. So we'll create a mean line, and then these are my error points. So this line is nothing but y mean, and if points are not there, then these are my error. So that is called TSS. What is that? This is actually total sum of squares. Okay, total sum of squares is nothing but I equal to 1 to n y minus y mean. So this is important difference actually. So let's put it in a different color actually, so that you can understand. This is y prediction, this is y mean. So once we find this two, so we first find the residual sum of square and then total sum of squares, and then the R square formula is coming here. So R square is basically 1 minus RSS divided by TSS. This is the R square formula, and R square value is normally we have R square value always greater than positive. Negative is a very rare scenario, especially this kind of package will handle this thing. So the based on the R square value, the high the R square value is, better the model. High the R square value, high R square, better model. Okay, but okay, I'll say in the next lesson, if there is no intercept, then probably that's a misleading information. So let me just write it. If there is no intercept, then do not directly consider R square. In that case, I will say consider only the RSS value. Okay, so I think up to this we are sufficient to understand the mathematical part, and now we can focus on the actual coding part, because my main intention is to help you to do the coding, and for that whatever mathematical background is required, whatever understanding is required, you need to know that part. Okay, so everything is very much easy, there is nothing very critical. So only thing, like from understanding perspective, probably understand MSE, how we are calculating this, and also try to understand why we are squaring it, then understand how we are calculating R square. This is another important aspect, and then in the later collinearity, how collinearity is impacting this solutions, that I will explain later. Okay, hopefully you like this explanation. Once again, if you like my channel, please subscribe it, and for any questions email me, I'm ready to help. So I'm starting my channel, so that's why I am very much eager to help anyone if struggling on this. I'm doing my masters, so hopefully I can help you. Thank you. Have a nice day. Bye.